Okay, so here's an application of the inverse matrices. So a great place this is used is coding and decoding. So if you think about your internet, and when you send things through the internet to your bank or whatever, everything gets coded and decoded through matrices. So what we do is we build a square matrix. We call it a coding matrix. For our example, it'll just be a 3 by 3 matrix, but last I heard these matrices are like 64 by 64. They're huge. And the concept for coding is that every character on your keyboard is assigned a number. So you build a message matrix and then you multiply it by your coding matrix. Well, we know the rule for multiplication, that if your coding matrix in our example is going to be 3 by 3, that the columns of the first matrix has to match the rows of the second matrix. So this first number of your message matrix is going to be any possible number. It depends on how big your message is. And to decode, now it's in reverse. You take the coded matrix and now you multiply it by the inverse coding matrix. But that's still a 3 by 3 matrix. So again, your coded matrix has to have a column number of 3 and it can have any number of rows you want. So if we were to make an example, say our message was GCC Math Rocks, you have to come up with a numbering system for your characters. Well, since we're just going to work with letters, we're going to let the space in between our words be a 0. And then 1 through 26 will represent the entire alphabet. So we'll count up how many characters we want. There's going to be 1, 2, 3, 4 for the space, 5, 6, 7, 8, 9 for the space, 10, 11, 12, 13, 14. Well, because we're dealing with multiples of 3, we're going to put an extra space to get to 15. If you ended up on 13, you'd put in 2 spaces to get and have 2 zeros here at the end. So everything has to count by 3s, again, depending on your coding matrix. If this was 4 by 4, then you would have in groups of 4s. So here 15 is 5 times 3, so we need a 5 by 3 matrix. Let's say it's going to be matrix B, and we're going to go store this in our calculator. So first, let's convert the letters into numbers. So G is a 7, C is the 3, and we have 2 of those. 0 is the space, M is 13, A is 1, T is 20, H is an 8, 9 is our 0, and let's see, no, letter 10, R, 18, O is a 15, C is a 3 again, K is 11, S is 19, and we'll put a 0 at the end. So we're going to go to the calculator, we're going to store that. So second matrix, go to the edit screen, put in your matrix A, we'll code that in first, then we'll code in your message matrix, which is the 5 by 3. Again, double check, make sure all your entries are correct, just like we did when we did our RREF commands for solving our matrices for our systems. So as it says, we're going to take matrix B times matrix A. That's the definition to code your message. So matrix B times matrix A is 0, 23, negative 5, 55, negative 76, 87, negative 28, 52, 16, 15, 6, 57, 43, negative 59, 111. Now, one thing I want to point out is look at, for example, the 3 3s. These numbers nowhere near close to each other. No giveaways. Look at where your 3 spaces are. Again, completely different numbers. Remember, your matrix multiplication is you're multiplying all those corresponding entries from your rows and columns and then adding those all together, which makes it impossible to break that code. So put these in order by rows, and this is your coded message. If we want to look at going in reverse to decode something, again, we'll look at our letters. count them up: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 again, 5 by 3 matrix. We'll call it matrix C. And we'll start putting these numbers in order. So you might want to group them in threes. So we're going 20, 39, 20, negative 28, 78, negative 21, 107, negative 128, 141, 136, negative 74, 53, 65, negative 71, and an 80. So again, we're going to go store that in matrix C of our matrix. Once you type them in, again, double and triple check all the numbers. And as the rule says, you're going to take this coded matrix, which is C, and multiply it by your inverse of your coding matrix. So inverse of A. And again, we let the calculator do that. So matrix C times the inverse of A. And your answer should have all numbers from 0 to 26, since this is what we're using as our key. So everything looks good so far. So 21 is a U, 14 is an N, and 9 is I. So that's the first three letters. 20 is a T. We got E and a D, so that's united. A space, a W, and an E. Space, ST. Then A14 was N and 4 was D. United we stand was that coded message. All right, so that's what inverse matrices are really used for. Some people want to use inverse matrices for solving systems, but again, like Kramer's rule, there's flaws and it doesn't work all the time, so I'm not going to teach it to you if it doesn't work all the time. So that ends with our section of 8.4.